Hello guys. So last time we did set up a system that basically understands where we are and what we have. And now I would like to create a different thing here. And what I want to do is I want to create a basically a format of displaying data. So data analysis, if you will. So basically what I want is I want to show straight flush, how many people have a straight flush, and then I want to see those straight flushes alone. What this means is we're going to take this data here, this section, and work with it. If you guys will give me a second, I will go ahead and work on fixing these up, and then we'll proceed to doing that. Alright guys, so here we are. I just condensed these and put them into those big blobs. So now the next thing I want to do is some kind of, some kind of fixing of this data so that it would make more sense. And this is going to have to be something more or less in brute force manner. First, what I would like to do is I would like to basically, I believe it's decimate. I've never used this before. Let us see here, Control Help H, and this gives us the elements by putting 0, 1, 2. It's put them in this manner. This is not what I want. I don't believe that is what I want, at least. What I'm trying to do is I want to get every single row out of there. So if I have to do this, it seems like I have to do this by array subset. I do not see why not. Let's go ahead and do this using the array subset. So I'm gonna input a for loop, gets in the data. Oh, this already gets it in row by row, does it not? Auto-indexed, yes it does, perfect. If we do that, and then we can go ahead and bundle each one of those into its own separate bundle, and then create an indicator of what we get. What we end up with will be basically a bundle, a line for every one of those, and some of them is going to have 30, obviously. In this case, the first one has nothing, but this here will control where we are. So there we go. This is very interesting to work with it this way. Now, the thing is that for most of these, this is enough, but for 2 of them, this is not even remotely close to enough. By looking at what I'm saying right now, I'm noticing that I can actually incorporate this into our design over here, but I'm not sure if I want to do that. Because instead of having an array here, we can just have a cluster, and in 2 and 6 the cluster would work differently. What do you guys think? I think that is a great idea. So basically this is what I want. I want to have just a single cluster that has an array of everything here. The only differences will be number 2 and number 6, which will have basically a 2D array because they're going to have 2 different arrays inside to describe that specific state. So here's what we're going to do. I'm going to do this we're going to have to change everything in here. The way this works will need to change in order to accommodate for this new system. So let's go ahead and do that. I'm gonna create more space and basically just open up everything so that we can work with it. I believe the end case does not do much, and then this one, there we go. Let's do the default case. So instead of having an array of a 2D array of 9 by 15, I'm gonna have only one with 15, and then what I will do next is I will have a cluster bundle built that will have one. Oh, if we have it, unless we do it in individual clusters which are arrayed. Yes, let's do that. So we have a cluster into an initialized into an array. I know this seems a little complicated, but we should end up with a very smooth running system by the end of this. So we have here, we're going to have that, and I'd like this array to be an array with 9 numbers only, with 9 arrays, each one having a single cluster. Then I would like to do a replace array subset. I want to take this array and I want to replace the index number 2 with a array of a double. This is where the number 2 and number 6 are going to come in. And that, I would like it back into a cluster and into this. Oh, that's not going to work. It's not going to let me put a 2D array into this when this is only a 1D array. This is an array of a cluster of a 1D array, and it's not going to let me put in it's not going to let me build a cluster array. Index and bundle, but I don't want to do it this way. What's the difference? So this is an array of clusters, and this is so the array must have the exact same thing inside of it, right? A cluster does not. The alternative to what I'm trying to do here is to basically create a single long 9-point cluster, which is not what I want though. Because if I do it this way and just substitute the 2 and the 6 with something else, then it will not look pretty. I'm actually confused right now, because I'm thinking about this and I'm thinking that even if I'm going to do this here, we now have an array with all of those, and if I were to take one of those and change it, that's not going to work. So here's what I'm going to do. I'm going to forget about this. I'm going to do the entire post-processing over here just as I wanted to. So basically by converting all of these into their own individual clusters, so it's an array that has a cluster of arrays. And then if I am to take the array and index each one of them and change it. Let's see, I'm going to create a second for loop. No. I know this might sound confusing, guys, and I do apologize for that, but I'm trying to figure out exactly how to make this work the way I have it in my mind. So hopefully this will not take a long time, but we can figure out. Alright, I'm going to take our default case system that we had earlier, and I'm going to empty it, because what we're going to do in here is going to be completely different. And in the case is going to be set by the I, this will tell us which case we're in. So the 0th one, what we're going to do is we're going to take the array, we're going to get an array subset of this one, and that subset is going to be simply the length of 15, and that is going to be outputted here with or without indexing, with indexing, while in the two and 6 case, you know what, guys? I just realized, why don't we make them all count as 2D arrays even though they're 1D arrays? So only one of them will actually be a true 2D array that we actually care about the 2D array of it. Would that work? No, that would not work, because then they would all need to have 2 arrays. Unless individually outputted. So here's the problem, guys. So what I was trying to do is this here, the ones that are 2 and 6, number 2 and number 6, for example here, will need to be cut up in half and put on top of each other, only for that specific one. And I'm trying to find a way to make that appear visually and still be nice. That's what I can't seem to figure out here. So let me think about this and I will get back to you guys. Alright guys, so here I'm trying to do this, the thing that I wanted to do, and trying to show you guys, right now I'm trying to show you guys what it is that I wanted to do. And this is kind of how I was expecting it to look like. So basically it would give us all the data in a very one-by-one kind of way. So we would know exactly what is doing what, if you want to call it that at least. So this is 3, 4, this here would be 5, number 6 would be appended, number 7 would be this, and that would be here the last one. There we go. So now I believe if I run this, this will be the decimated version of this, but my way of decimating. So basically, as you can see, this should show us, for example, the 18 from here and the 12 from here, right? So this here is the 2 pair, and now indirectly I can tell you that the 2 pair is a combination of these two. If I were to get detailed and want to know exactly which 2, then that I believe is just too much information and we shouldn't have to deal with it. I hope you guys agree with me when I say that. So this is basically what it was I was looking for, and this should essentially, let's make this smaller, make this just about 2 squares and a little bigger. It should go all the way up to the ace. So as you can see, there's a 2 pair, and there's a huge likelihood that one of those 2 pairs is an ace and the other one is a 9, or it could be an ace and one of those, or it could be an ace and one of those. So it's a combination between these 2 numbers. Again, if I were to make every 2 number combination, I know there's only 13 of them, but 13 times 13, then you're talking about a large 200 or something number of possibilities. And they don't really matter that much. This is just a small technicality to give you a small added edge on wherever you are in this thing. I would like to perhaps be able to have a system similar to what we have right here and have these aces showing up and then highlighting basically each one and what the possibilities are, and give it a value. This is something that we'll work on way later on. For now, I like this system. So basically we took this, we divided it up, so first 15 and second 15, and each one of those was then further divided to get this kind of view right here. So I'm going to delete this big long one because we do not need it anymore. All the data is now represented in these over here. And that is what this thing does. Now I'm going to go ahead and try to fix this up, make it look prettier, and get back to you guys. Hey guys, so for the sake of simplicity, I've been looking at this and trying to figure out but thinking this is way too complicated to do. So I came up with this really interesting idea, and I'm about to test it right now. I'm not sure if this will work, but I'm hoping it will. So if this is outputted as an array, can't I just do this? No, that did not work. Because this is also an indexing. Okay, so if I index this one right here, and then let's say I want to see this. So we have 1, 2, 3, 4, 5, 6. So this here is this should remain the same. That is perfect. Alright, so what I just did was I took all these and convert them so that we don't have to do these two combinations. These two combos have been put into the system so that we do not need any of this. I can have now a single standard for showing the results, and I don't need to worry about anything else. I hope that makes sense. So now each one of those can basically be linked up to directly one appended array. And there's 9 of them. So there we go. So this is this one. And then any array that I want, for example, this one, as you are about to see, will have 2 identical numbers. But the beauty is that I can just show one of them. I don't need to show both of them. Once I get rid of all these sides and titles, then this is all I care about. The only one that has 2 are going to be the full house and the 2 pair because of their because they require 2 numbers. And there we go. I'm not sure what to call this. Let's see, what did we call that? We called outcome subdetails. So this one here should have probably a similar name. So we could call this, for example, let's see, we can say the subdetail. I'm not sure what to call it. Can we interpret what I just did here into this system though? If we are going to do that, then we would need to create 2 15s and have them built up at the end. I think that is a good idea. I think it would be a good idea to just combine these two together instead of having this done again for every single one of those. Even though there's hold on. This is done 1,000 times. This n is processed 1,000 times, while this n is processed 9 times. Then we're going to need that. So outcome subdetails, and then this will be the subdetails. I'm not sure what to call this. I'm going to just say arraying. There we go. Subdetails arraying. So this will basically convert them into these 9 arrays. Sum of each outcome. This here also is a form of whatever we have here. What I could do is I could create a cluster kind of system between this and that to have a match, but I'm not going to do that for now. For now, I'm going to end with this subdetails arraying, and now we have a single array for every single one of those. Later on, we can give it names. So, for example, this is 3 of a kind. 3 of a kind. I'm going to put that for now only, and this one here. Oh, I'm sorry. This is not 3 of a kind. This is 2 pair. This is the 2 pair. And this one here is the 1 pair. And so on and so forth, they will have their names. So now I see, okay, there are 66 2 pairs, which is the sum of all these numbers here, which is the sum of every single row of those, right? Remember, this is a combination. So if we are to add 30 plus 21 plus 12 plus 3, we should get 66, and we add these up, we get another 66. That's how this works. Alright, the next thing I would say is to try to create a better visualization of this perhaps, or even to eliminate the options that are purely based on what the table has at the end, if we will. So if something is on the table, then basically we should not say that it is special because everybody has it. So let's see how we're gonna do that. That, as we had discussed, will need to be added all the way back here with the all possible hands, where what we did was insert into the array the 2-card combo. The 0th option is gonna be your hand, and then I think what I would like to do is have the first option be a 0-hand combo, so basically just what the table has, and then this one over here. So let's see if I can do that really quickly here. If this is as easy as it sounds, then in essence all we need to do is, and I need to make some space here to work, if we want to leave the hand as our 0 option, then our table, having basically no hand combo, should, let's see, if we do insert into array, so insert into this array before processing it out there, new element, create a constant for that element of 0, 0, 0, right? Visible items, index array, ding ding. I think we need to put in 0, 0. Let's see what this array looks like before, and what does this array look like here? It's array 4, which looks like that. Okay. Well, let's see how array 4 will change. It should add 404, 304, 00, 413, 412, and so on. Perfect. Perfect. Now, it seems to have worked the way I wanted it to. Let's see if we can just briefly fix this up. Can I add the second one in here? Yes, I can. Alright, so there we go. All possible hand combinations have now been adjusted to include the second hand combo is the table. The second hand is the table. So if we come here, and this is the element, this is basically what you have, and then you can actually now see what does the table have. So the table owns the second possibility. The table has the 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. The table only has a high card. In this case, it's a high card ace. So I know what the table has. Perfect. So now we know that, okay, there's only a high card on the table, and we know that, okay, you have a 5. Now, what does everybody else have? That's what these do. Now, what does this mean? Well, the 8 here will need to be reinforced by the first 2 of whatever is here. So these here, these 2, should reinforce what the first number just told us. I'm not sure what these arrays are anymore, because there's no indicator of what they are. Let's go ahead and see. These should be 2 numbers, right? 2 numbers. There we go. These give me 2 numbers that determine what is what. So there we go. this is the hand, and this is the table. So basically this tells me that I have a 5, 0, 1, 2, 3, 4, 5. I should number these out here. 0, 1, 2. Once we have a better display, then all this will be much easier. 5, 6, 7, 8. And these values will be all interpreted, so you can very, very easily know who has what. So here we see that there is we have a 3 of a kind of 4 of the value 4. What is 4? I think 4 is 4. I'm pretty sure 4 means 4. But then what does 18 mean? How does this have 18? This has 18 only because it is 0, I believe. The only way that this has 18 is because it is 0. It is probably the only 18 in the entire thing. Yeah, I'm pretty sure that's what happened here. There is an error somewhere with this. We'll go ahead and check that out in our next episode. I'll see you then, guys. Bye.